Good afternoon and welcome to our latest NEXUS webinar. My name is Jaya Calder from Highlands Enterprise and I'm going to be helping you run the webinar. Before I pass on to my colleague Andrea, I'd just like to go over a little bit of housekeeping. Although we can't see you and you're automatically muted, we are actively looking for your involvement. So you should see a question box. Please, at any point throughout the webinar, pop your question in or pop your comment, and then we will come to that. I'll make sure that your speakers get your questions. The other thing is, if we've got time at the end, because we will have a Q&A, we're happy to take anyone off mute and we would love to hear from you. We are recording today's session. Now, we won't be sharing the slides as a separate entity, but we will be sharing the recording. And when that's ready, what we'll do is we'll be emailing it a link directly to you. So let's get started on this afternoon's Augmented Reality webinar, and I'd like to pass to Andrea McCall, my colleague. Andrea.
Thank you, Jaya. Thank you for joining us today for the webinar. I'm Andrea McCall. I'm from the Life Sciences team at Hay in Inverness. And the NEXUS webinar series is really an opportunity to find out more about what's going on in our life sciences, health and technology community and make some connections as well. And in case you don't know, NEXUS is our co-working suite in Solaster House on Inverness campus, where we have life sciences and technology companies co-locating and collaborating. And NEXUS is funded by the Inverness and Highlands City Region Deal and the European Regional Development Fund. So let me just show you my next slide, which is just really to introduce our speaker. So I'm delighted to have with me today Professor Will Shu. He's the director and co-founder of Organlike, but he's also a professor of bioengineering at Strathclyde University in Glasgow. So he's going to tell us a little bit more about, obviously, his business, Organlike, but also, and obviously the products they produce, organ models, but also how augmented reality tools can enhance medical training in addition to the organ models. So handing over to Will now.
Thank you, Andrea, and also thanks for the invitation. So so very happy to be here. So I'm glad to share some of the experience we have in Organlike, how we use augmented reality to develop a surgical training program. So today I'm going to first talk about a little about Organlike, our company, and also give you some introduction about augmented reality and how we use AR technology for medical training. So our company is basically founded in 2017. We chose Inverness campus as our headquarters because we have our strategic partner, Scottish Surgical Bootcamp, just next door, which is really very important for us to validate our technology. And also we got a lot of support from Hay and this lovely Solaster House to be our headquarters. So the technology of our company is basically based on our research vision in my laboratory to basically use 3D printing technology to print our solid organ, and one day we can use the solid organ for medical transplantation. So this is really something was considered as a science fiction just like 10 years ago when we started journey. It's still very challenging, but is now actually the technology has shown that this can be realized in one day. But before that, before we can use that technology for medical transplantation, we thought, well, maybe the underpinning technology can also be used for some other applications. So that's how we actually founded Organlike, to develop the organs using organ printing technology for medical training and simulation. So the problem is, well, for surgical training, traditionally is very limited because first is limited by the specialized locations. You have to do it in either hospitals or medical schools, particularly you require wet labs. But also the material you use for surgical training requires, either cadavers, animal tissues, or even in many cases, live patients are not always available. And that leads to the problem of inadequate surgical training. So inadequate surgical training cause medical mistakes, which is one of the leading cause of death in US, and also is a global problem. Annually, it costs more than 42 billion US dollars. So it's a very big problem economically and also for the society. So we are teaming with Professor Angus Watson and his team in Scottish Surgical Bootcamp to basically validate our technology of organ printing, these soft anatomical organs for medical training and simulation to train future surgeons. And that was really quite successful. We actually together, we helped to develop the first program of home-based simulation using our models for training open vascular surgical skills in the UK and Ireland. So the idea is, as you can see here, we can send our organ models like artery in our surgical training boxes with all the tools needed, and to the surgical trainees. We can even send to their homes because our models are not derived from any human or animal tissues. So it can be safely used in home domestic environment. And then the surgical trainees can actually perform their, can practice their skills at home environment, and can be recorded. So this program was very successful and was awarded an IHR MedTech Prize 2 years ago by the British Vascular Society. And also that helped us, Organlike, to develop our product for not only hospitals, we also sold to medical device companies to demonstrate their surgical products. So everything was going very well until exactly 1 year ago, last year, when WHO declared this COVID as a pandemic. So that inevitably impacted on many business, many families, and also the whole society, because hospitals were basically focused on how to, well, still now, how to face the challenge of COVID, with many surgery have been cancelled, and also many surgical training have been cancelled as well. So for our business, we were thinking how we could really survive this pandemic. One of the key problem is for surgical training is, as I mentioned, is very limited, is centralized, and and rely on the material which is not always available. Organlike can provide new material, but it is still, how we can provide a technology that can provide the enhanced experience like what they can traditionally do. Surgical training is a big challenge for us. So for that, we thought about technology. Is it possible for us to actually incorporate our organ models with digital technology? So for that, we thought about, well, how about augmented reality? So for many of us, actually, who are not familiar with augmented reality, we may have already used augmented reality previously, including myself. I was a big fan of this game called Pokemon Go, and as you can see here, basically the game is basically overlapping the real world environment with the digital generated virtual content like this Pokemon, together, and give you a very immersive experience of the game in real time. So what is augmented reality? It is basically adding computer generated virtual content to the real world environment in real time. So, many of us have already used AR technology, but not realizing that. And this AR has been, has a huge potential and have been used in not only in gaming, but also, like this is possible, for the future communication. You can even turn your phone virtual to basically make phone calls using the technology. And IKEA has already developed this AR technology for you to choose furniture inside your home. Basically, create this computer generated furniture in the app, and for you to see whether the furniture can fit in the home environment. And also has been used for shopping. So I'll give you one example here. So this is in Walmart in China, and you can first create a shopping list. And this will lead you to the first item. But hold on, maybe your friend would recommend you to buy some grapes. So this is an interesting app, basically guide you to shop, and even it's possible to play Pokemon a little bit before. Yeah, so that's Pokemon, and then lead you to yeah, as you can see, that's the item. and milk powder. Yeah. Well, you can see the review, and then make your decision for the next one. So yeah, so AR has been used for for many applications, even including surgical training. So as you can see here, you can, well, the surgical trainee can actually just take their smart goggle device and see the virtual environment overlapping with the surgical theater. And it's also possible to get a 3D anatomical structure of the teeth out from a textbook. And it has also been used by surgeons to actually do surgical rehearsal, basically discuss about how to do the surgery together. So that was a a simple idea that we would like to use the digital technology AR to enhance our experience of surgical training. So for that, we took the idea and applied to Innovate UK, and very fortunately, Organlike working with Royal College of Surgeons of Edinburgh and also NHS Highlands, together we secured this new project, we call it Homes Training, to basically develop our digital technology, our AR app. This is in collaboration with the digital team in Strathclyde University, where you can see this is just a prototype. So we send the artery to the surgical training, surgical trainees, and we don't have to send the whole organ to the trainee, but just a part of the organ, and the rest of the organ will be illustrated by the AR technology. So we can have, so that the surgical trainee can have this very enhanced experience by the AR technology for the training. We also benefit a lot with our neighbors in Solana's house. So we'll also work with 4C Engineering to develop this surgical box for the AR, working with the mobile phone, and not only as a holder, but also has this all the surgical tools needed for the trainee to perform the training experience. So we can have the whole package sent to the trainee so that they can perform their surgical training anytime, anywhere. And this is, we're very proud to see that, 4C can manufacture so many boxes for the program, for the project. And we are also sending hundreds of boxes to our African collaborator to validate the technology in Africa for the surgical training. And very recently, we also developed the idea with a group of surgeons in Guyana, South America, and got funded by Intuitive Foundation, which is which is the, well, Intuitive Surgery is the manufacturer of the biggest manufacturer for surgical robot in the world. They found a program on this global surgical training challenge that we are very fortunately is a recipient of this Discovery Award to develop this simulation-based training program for developing country. So that also incorporate our AR technology. So finally, what would be the future? I think, you know, people can already develop this surgery that can be performed remotely. You don't have to be in the same theater to do the surgery. And that's why we are very confident remote surgical training can be realized, and it could be the future. And in order to do that, we actually do need to really develop AR technology to incorporate that to make remote surgical training, well, surgical training not remote. And finally, I would like to thank many, first of all, HIE for many years of support, and also all the collaborators we have for our company. Thank you very much for your attention.
Thank you very much, Will. Well, Will's got a slide up there saying any questions. Now, although we haven't had any questions, we've had just a couple submitted. We've got time to take our audience off mute, which I always think makes a much better webinar. And I'll invite Andrea to come in and put her camera on as well just now, and we can look at the questions. But Will, you talked about, you know, science fiction, and in effect, you're turning it into reality. But looking at it from a customer point of view, what are your customers saying? How does it feel to actually train on a 3D organ and a kit that's potentially sent through the post? Is it the same experience?
Well, this is something, you know, we we'll keep engaging with our customer end users, you know. So our intention is definitely we want our customer to feel exactly the same way, to basically get a training from our models exactly like the same way as the real organs. Okay, and we're getting there. We're still not there, but the good news is what we found out is, in fact, our models, although it's not as good as the organs in the live patients, it is actually better than that of cadavers. You know, in the cadaver, the tissues are quite different from the real live patients, as you can imagine. You know, it is basically either from the water content or from the mechanical property. The tissues in the cadaver is no longer as close as a real, you know, live patient. So what we found out is currently we are somewhere in between the cadaver and the live patient. And our hope is we can get closer and closer to the real live patient, but it's already better than what most surgical training is using, which is cadaver.
Thank you very much, Will. Now, I've got a couple of questions in from the audience, in fact, more than a couple, and also I'd like to come to Karen, and I'm going to take Karen off mute and we'll speak to one of our customers. Good afternoon, Karen. If you can unmute yourself at your end. Hello?
Hello, can you hear me?
Loud and
Yes.
clear.
Excellent. Well, that was really fascinating, what you've told us about there, and some of it is almost so good that it feels difficult to believe that it's true. And I think it's amazing that you've made so much progress, particularly on the training front. But I wondered, you'd said that the original idea was to produce 3D models for transplants. Is that still your vision? Is that the way you're still heading, or are you focusing on the training at the moment?
Well, yeah, thank you. Yes. Well, that is always our, for creating a solid organ for medical transplantation is always my dream, and um, as as you know, actually, I also have my research lab in university, and that is definitely the vision we are still pursuing in my research laboratory. Yes, we are still working on that. My hope is we can actually create solid organ for transplantation before I retire. So that's my dream. But for the company, I think we have to be we have to be more realistic for the time we have. So that's why we dedicate the company for the more achievable aims of medical training and simulation in the shorter and the medium term. But for the longer term, that's that's our research vision. Hopefully that would merge together in hopefully 10 to 20 years time. That's my hope.
Thank you.
And just to think that all our current students who are just about to go away after the summer and become medical students, this is going to be their norm, which is a great thing to think about. Now, along the same lines, our next question is, it's really great to see you moving forward with the company. And we touched on a little bit, but what are your plans for future products?
Well, yeah, well, the future product, we think for the company, our vision is basically make our product as realistic as possible. So that's our ultimate aim. We're hoping we can create a product that give the trainee exactly the experience which the best experience they can have, the best model they can have, which means that our model will be as close as real organ or really like a real patient as possible. So our future product could be the bespoke product, which would match the patient's individual anatomic structure. Okay, currently we make a batch of product for well, not necessarily based on some individuals' anatomic structure, but in the future we're hoping we can create this product on demand. And we start, then we are hoping we can extend the product in the hospital, so the hospital can actually use our technology to print patients' bespoke organs, either for medical rehearsal or surgical planning applications. So that's our hope. We can get there.
Thank you very much. Now we're relatively, a young company, over the last 4 years, massive progress. So we've got a question, where would you like to be in the next 4 years? And also, what's your biggest challenges and opportunities that are going to face you, say, in a 4-year period?
Yeah. Well, I think, we, in the next 4 years will be very important. We, in the past 4 years, we basically established ourselves. We identified a viable product, by engaging with our end users, which really educated us a lot. We started from something completely different, and the reality is, by interacting with our end users, we know this is something our end user want, which is quite different from what we started. So I guess, in the next 4 years, we want to really scale up the technology, and we're hoping that our end user can use our technology in larger scale. So our end user, including hospitals for their hospital training, medical device companies, Royal College of Surgeons, and many surgeons in both UK and many developing countries. We are hoping we can actually grow our company in a scale, so that there are many challenges. We need to raise our funding. We need to also developing technology further to make it more effective, more cost effective for our end users. In terms of the biggest challenge, I think is, well, maybe like many other businesses, I think the biggest challenge is to have the product really can penetrate the market. We think we have opened the door for the market, but really have the product can be which can lead to larger scale sales. I think that will be the biggest challenge for our next step. We think we are, the direction is right, but how to get there, we actually really need to engage further with our potential end users and get there, hopefully, in the next 4 years.
Thank you. Next question, got another couple more. I'm trying to get through as many as we can, because you've obviously touched the interest button on a lot of people. What are your thoughts on using virtual reality for surgical simulators as opposed to AR?
Yeah. Well, I think virtual reality basically, like our AR, is a two aspect of the same immersive technology. Basically, try to immerse the reality with all the technology. The virtual reality, basically, everything you created is virtual, right? So it has its own advantage, because it's not relying on the real environment. Augmented reality basically overlapping the virtual reality with the real world environment. So I think both has its advantage. For our Organlike point of view, because we specialized in providing this hyper-realistic organ models. So obviously, we would like to use the augmented reality with our real organ, combining together. Additionally, I think because surgical training is a very hands-on practice, the surgeons, trainees really have to touch the organ, touch the tissue, and to practice. So these psychomotor skills are very important. I think that's something augmented reality can really add a lot of value, as opposed to in comparison to virtual reality. Virtual reality is really nice to see the whole procedure for training, but it cannot replace the the psychomotor training by touching, can really touching the physical model. Yeah, so that's my opinion on that.
Okay, now moving to the work that you do on a global market, how much collaboration is there with like-minded companies, bearing in mind that you're all individually businesses at the same time, but where does collaboration fit in for the development of what you're doing with others?
Yeah, we are already working with surgeons internationally. So we are working, as I mentioned, through this global surgical challenge program, Discovery of World. We are already working with surgeons from developing country like Guyana, and also there are a group of surgeons from US who are working with us how to turn our models to train cardiovascular surgeons. So that's one example. And we are also having opportunity to work with big medical device company like Medtronic, like Intuitive. So they are actually quite international company. So we have the opportunity, very fortunately, to have the opportunity to actually work with their branch, not only in the UK, but also have the opportunity to know the need of their, global, their global need. So in terms of that, we actually are collaborating with mainly big corporations, which has this global reach. So through that channel, we are working with the international players.
Okay, and the final question that's come in is, what excites you about the area that you work in? What do you love about it?
Well, personally, yes, what I really love about this is the opportunity to work with end users. Basically, can really apply our technology for practical applications. I have been, working in research labs for, over 40 years, over 45 years. Well, no, over 30 to 40 years. So in research lab, it's really difficult to actually turn our technology for practical applications. And really excite me to actually have a technology that can be recognized by the end user and found these practical applications. So that's really make me excited, and that's one of the main drivers personally for me to do this. We can actually really translate our technology for something really useful.
Thanks, Will. Andrea, is there anything you would like to add to the question panel?
No, I was just, thinking that it is, such an inspiring, idea product that you're developing, and you can really, as you're saying, the application, in real life with your end users, with the surgeons, is very inspiring. And you always wonder, what will the world look like in 40 years' time? Because we know it has moved on. Technology has moved on so much in the last 40 years. So, what will be possible? And it feels like what you're doing, will definitely part of the future. So it's very exciting to see it happen at the moment. How you're getting on at the moment, and how much success you're having at the moment developing this further. And as you said, it's not an easy journey, but I think it will be worthwhile in the end. So it's fantastic to see.
Thank you.
Thanks, Will. Over to you, Andrea.
Yeah, so just wanted to thank you, Will, for joining us today. I know you're a busy person and you have lots of things going on, obviously, between university and the business, but it's been great to have you and hear you talk about what it is you're doing and how successful you're getting on at the moment. So just wanted to say to your audience, thank you for joining us, and we're looking for your feedback. So after the webinar closes, you'll be sent an automatic feedback form, so you can fill out, let us know what you thought about today's session, and maybe suggest even other speakers that you would like to see in the future. And also just to draw your attention that our next NEXUS webinar is planned for the 25th of March in 2 weeks' time, and we'll be joined by Kirsten MacLeod from Scottish Vet Referrals, so another company that's based on Inverness campus, and she basically runs a very specialist vet practice. So it will be interesting to hear from her about what they do, and again how they have found Inverness campus to be quite a collaborative place to be, and how they are working with some of the other organizations on site, similar to what Will was talking about today, working with 4C Engineering and with NHS Highlands. So looking forward to that talk, and I hope you can join us for that. Please look out for the invitation in your email or on social media. Thank you.
Okay, thanks to Will, thanks to Andrea, and thanks to our audience, and we hope to see you at our webinar very soon. Okay, bye-bye now.
Bye.
Bye.